Namaste everybody, it's me H.N.Upadhyaya, mathematics teacher and principal of Scholars Home Academy, Samakusi, Kathmandu, and my objective is to simplify mathematical concept. Mathematics has been very difficult, hard, tough, abstract, like this to school level children, and they do not want to have their mathematics classes because they are not given opportunity to touch, feel and see mathematics. And to help them touch, feel and see mathematics, I have arranged today a kind of class named Mathemagic, the magic with mathematics. Learning mathematics with magic is our objective. Demystifying mathematical concept by using materials, that is another theme. So under this theme, today we are going to demonstrate the surface area and volume of different kinds of pyramids, and for this we are focusing on square based pyramid, and that is generalized to other pyramids as well. And with me today is SHA Acharya, class 10 students, and Rosna Sapkota, class 10 students. It's the class 10 content. Okay, good morning girls.
Good morning, sir.
Okay, what are you doing today?
We are doing something magical.
Magical, what is that?
We are building a pyramid by using this paper.
Pyramid by using paper. How can you do it?
Just observe me.
Okay. Rosna, what are you doing?
I'm also doing the same.
Same thing. Okay. Let me see how you do it. So this is, what is this called? It's the net?
Yeah,
Net?
it's a net of pyramids.
Net of pyramid. Okay. Alright. Rosna, in your net I could not see lines within, Can you draw there? Alright. Okay, so here also I could not see the line. So this is the net of pyramid, you said, yes? And it falls into a net.
Yes.
Okay. So magically you are learning mathematical concepts.
Yes, sir.
Very good. So you cut along the boundary line, is that?
Yes.
Alright, along the boundary line, and after that perhaps you fold, yes?
Yes.
And glue it.
Yes.
So people think mathematics are rather difficult subject, and in your observation, what do you feel? Is it difficult or is it interesting, funny, joyful? What do you think and how you perceive it?
I think it's absolutely joyful because if it's magic, then everybody should enjoy it.
Okay, that is good, great. When mathematics is associated with magic, and the common word we can say mathemagic, and combinedly working magic and mathematics both at the same time. It's really a great concept. Actually, in every school, students should have an opportunity to do this way, I guess. You don't need to draw that one, I guess. Yeah? Okay. Now, yes. This looks really good. You need glue sticks. Okay. So glue them up. Now, if you fold it this way, actually keeping the ruler like that and holding it up, and then becomes easier. You try this way, okay? You try that way. So hold it up, keep it in your, this way, not in the table. You will feel difficult to take off the piece which is together with the table, So you can do that way. Alright, so Suyasa, have you completed this?
Yes.
Rosna is doing. Okay, you tell me, what type of pyramid is this?
It's a square-based pyramid.
A square-based pyramid. So why did you say square-based pyramid instead of saying triangle-based pyramid, something like that,
It's because while identifying the bases, we look at this part.
Okay.
As you can see, this is a square, so it's a square-based pyramid.
A square-based pyramid.
Yes.
And Rosna, yours is what?
Square-based.
Square-based pyramids. Okay, let me check both of them. So what's the difference between these two? You have said this is the square-based pyramid and this is also the square-based pyramid. So, okay, so it goes this way. Anyway, I do have similar type of pyramid with me. I'll just help you to know from this. I have this pyramid or this one, at the same time I do have this one, and I do have, okay, this one. You know, you said the one which Rosna made is this,
Yes.
and the one which Suyasa made is similar to this. And they said, you have said that both of them are square base pyramid, and I have asked what is the similarity between them. And before discussing on that one, you know why you have said square base pyramid? Because it has the base square. And what will you say to this? Perhaps it has the triangular base. And what type of pyramid is this?
Triangular base pyramid.
Triangular base pyramid. Okay, absolutely correct. And what type of pyramid is this?
Rectangle base pyramid.
Rectangle base pyramid. It's the rectangular pyramid. And this one is it is hollow, you know. Pyramid may be solid or hollow, and it is made of 1, 2, 3, 4, 5 sides, and it is pentagonal based pyramid. So pyramid are named according to the base. Are you sure about that?
Yes, sir.
So our class today is something about magic with this shape, and we have said that it is the class Mathemagic. Yeah, it is a class on Mathemagic. Okay, so we are going to make magic from this one. Our magic starts like this. First of all, with Suyasa shape. Let me take 3 of them. They are identically equal. They are congruent to each other. The face overlap each other, you know, like that. So these are congruent pyramids, square base pyramids. We have 3, and these three pyramids can be kept into base like this: square base, square base, square base. 3 bases for 3 different pyramids, you know, like that. You can keep them this way, you know. Look, yeah. And if you fold it, it folds into what? Can you imagine?
Square.
It folds into a square. Your answer?
Cube.
Cube.
Oh, I mean cube.
You mean cube. So why did you say square? Because a cube has square faces. You might have one. So now I have the ready-made one just to help you to know about that one, you know. So these three similar activities are here. These 3, you know, they are in 3 square bases. First, second, third. The same pyramid over here, you know, exactly in the same way. Let me say that they are sitting this way. Okay, and then when they are folded, and they make a cube. They make a cube. And about cube, today, you know, we are going to do the volume and surface area of a pyramid. Volume and surface area of a pyramid. Now, what we know from this one so far is that, you know, 3 congruent pyramids. Let P stands for pyramids. 3P, 3 congruent pyramids. 3P is equal to 1. C stands for cube. You have 3 pyramids make 1 cube. 3 pyramids make 1 cube. Okay. So this cube has the volume a cube. This has the volume
A cube.
a cube. Okay. And this a cube can be written as a square times a square times a. When we take the square of the side of a square, let me say, this is the square base. It's the area of the base. Let us say that is base area denoted by B. And actually each pyramid here, you can see the height of the pyramid is exactly equal to the cube. The height of the pyramid is, this is the one of the side of the cube, and here it is the height of this pyramid. Okay, so that is why, you know, when you fold it, each pyramid will have the height equal to cube, side of the cube. Okay, so then you can write H over here. Yes, then 3 pyramids equals to that. Therefore, you can say 1 pyramid, just 1 pyramid. The volume of 1 pyramid equals to 1 over 3 base area into height. So this is what is something magical conclusion using this material we have made. Okay? Did you understand this concept?
Yes, sir.
Any question? Do you have any question, confusion? So what we have done so far is that every pyramid is made of net, and that pyramid we make from the net is defined by its base. The base, if it is square, it is square base pyramid. If the base is triangle, it is triangular pyramid. If it's rectangular pyramid, and this kind of approach holds true for any different kinds of pyramids. Now let us see something differently. Same type of conclusion can be made for Suyosha's what is this pyramid. If you check these pyramids, both of them have the square base, same base, and they have the same height. You can see they have the same height, stand on the same, exactly. The ruler is balanced to some extent, so it is balanced, means that it makes the same plane, this and this, two parallel planes. Therefore we can say that these two cube stand on the same base and between the same parallel, and they have the same volume. Like in geometry, triangle on the same base and between same parallel have same area. Similarly, pyramids or the solids, congruent solids, not congruent really, solids on the same base and between same parallel have the same volume. Pyramids on the same base and between the same parallels have the same volume. So that is what is the conclusion for today's presentation. Now let us experiment this thing somehow in different ways. For example, let me have some pyramids like this: 1, 2, 3, 4, 5, and 6. You have these pyramids there, and this pyramid in this net. Okay, so one goes there, another goes there, the next one goes there, and the other one goes there. That way you can keep these things together. You can keep this thing together. All right, and all of them are based on congruent squares. And I have the ready-made one made by myself, but you can check. So look, these 6 pyramids, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 6 pyramids are kept in a net like the one I have shown you before, yes? And this can be folded into a cube. This can be folded into a cube like this. Okay? This can be folded into a cube. And now you can imagine, previously 3 pyramids made one cube. Now 6 pyramids made one cube. Can we find the volume of one pyramid, using this configuration, this solid, this structure? Okay, that's what we are doing today. And now let me help you know this thing. Like this. Here you have again 6 pyramids make one cube. One cube has a volume, a cube. Yes, a cube can be written as a square times a. Yes, and this a, no, it's not the height actually. Here it's not the height. A square is the area of the base, and this a, what is this? We have to define it somehow differently this time. How we define it is like this. These 2 pyramids, when kept together face to face, they make the opposite bases or opposite faces of the cube. Means that the height of this pyramid is half of the side of the cube. Half of the side of the cube. If you put it together like this, you get the same thing. These 2 are facing each other and the top are meeting together. It means that this is the height of the, side of the cube, which is double of the height of the pyramid. What is this? Double. The height is half of the side of the cube, and the side of the cube is double of the height of the pyramid. Okay, that's the same meaning, same thing. Now what you do is, let's say a is equal to double of height of that pyramid. Yes,
Yes.
You can check it, it looks double in height to that one. So it's obvious, yes? Obvious. But if this makes the cube or this makes the cube, and that they are also making the cube, means that their height is half of that one. Okay. Now one pyramid, therefore one pyramid equals to, what is that? B times 2h divided by 6 ultimately becomes 2 3s are 6, that is 1 over 3. You can cancel also, 3, yeah, base into height. Therefore volume of pyramid is equal to that one. This is the magic conclusion we have done. So whatever material you use, however you interpret this thing, whatever be the situation, but the result is the same with different kind of materials. So from this one we can conclude that the volume of pyramid is 1/3 base area into height, and it does not apply. It does not apply only for the volume of square base pyramid. It also applies to any different kinds of pyramids. For example, if you have a rectangular base pyramid and that makes the cuboid, in place of cube that makes the cuboid, and the volume of the pyramid is 1/3 volume of that cuboid, circumscribing cuboid, So that way, again, the volume of the cuboid is base into height, 1/3 of that is 1/3 of base into height. Any confusion, Rosna?
No, sir.
Suyasa? So happy today?
Yes.
That's very good. Great. So we had a great experience today, yes? So if you take this type of square base pyramid, it folds, this side folds up there, and you get this type of pyramid. So this is the net of this square base pyramid. So this net is a plane, this net fits exactly in a plane, So it's a plane shape. The area of the plane shape is now combined with, of this plane shape or this net is combined with what? This is combined with 4 different kinds of triangles and a square. So we know the area of the triangle, we know the area of the square, and we know the area of the triangle. And all these are congruent triangles, These are what kind of triangles? Congruent triangles. You can see, so this triangle is congruent to this one, and another is congruent, and similarly the next one fits exactly, that's why it is congruent, and this fits exactly, that's why it is congruent, These are congruent triangles. So here the net of this one, if it falls into the pyramid like this, then the area of this net must be equal to the area of this one.
Yes.
Now the task becomes simpler, So that is why let's try this way. The area of the base, assume that it has the side A units, the base, it is the base, yes. This base has the length A, okay. And then what can you say? What is its area? Its area is A square. We have obtained the area of that one is, what is that? This is A square, I will not write it there. A square. And similarly, we have triangle like this, and this fits exactly to the side of that square, fits exactly. Yes? That means the base is also A. In this one, base is A. So it has the base A. Area of the triangle is equal to half of the base into height. Height is the slant length. We say this length of the pyramid is slant length. The height is the slant height. We can say that one. So that is what we say is L. L is the slant length. Yes?
Yes.
Then how many triangles are there?
4 triangles.
4 triangles. Therefore, you have 4 triangles equals to half into 4A times L. Okay? So let's write it in language. This is half 4A. 4A is the perimeter. A plus A plus A plus A. 4A is the perimeter of the square base. That's what we call perimeter of the base. P into slanting length L. So half perimeter into slant length L gives you the surface area, slant surfaces, the area of the slant surfaces. And to this one, if you add to this one, if you add the base, you will get the total surface area of the pyramid. Okay, so we have now total surface area. You can say TSA is equal to area of the base A square plus half perimeter into L. This is the total surface area. And from the total surface area, if you take out that area, it gives you the lateral surface area. This is called lateral faces, lateral surface area, LSA. LSA, lateral surface area, is equal to, you cut out A square, and the left thing is half times perimeter of the base into slanting length. Here you are. And similar thing with those triangle, if you find it confused one with this part, are you confused with this a little bit? I can make it clear by other way. Okay, alright. So then you have the shape like this. These four triangles are arranged this way into the form of parallel. This is the base triangle, it's congruent. Once again, you can check. It overlaps this triangle, you can check that way, You check it this way and that way. So those four faces are arranged into a parallelogram. Area of the parallelogram is base into height. Area of the parallelogram is base into height. Area, let's say. Area of the parallelogram base into height. Base is what? Base is A plus A is 2A. 2A into height. This 2A can be written as half of 4A into H. And look, this one and that one is the same. In place of H, we have substituted L. Therefore, this is LSA equals to half times 4A into height is L. Same thing. Okay. So it goes there actually. It goes there. So we have, so far, we have used this parallelogram and we have worked out this area as the base into height. Base was 2A. 2A into height is the area of this parallelogram. And this 2A was written as half of 4A to make it perimeter. And height was replaced by L because the height is the slant length of that pyramid. So you have LSA, therefore LSA, this is the same to LSA. LSA is equal to what's that? 1 by 2, 4A
into
L. Okay? So girls, how do you take it? Today's class, how is it?
Very interesting.
Very interesting, great, yeah? We have done the great work today. So math is magic. Not only maths, people say it is a headache, it's dry, it is dull, it is abstract. Oh, no, it is not. It is concrete. We can touch, feel and see mathematics. You have touched everything here, you have felt and you have seen what we have done here very transparently. So that's the objective of today's presentation. You can send your comments to us and that comments helps us to develop our program in the future. For that one, you can remember me or you can call me at 9851016 or you can mail me H.N.Upadhyaya Google Mail.com. Thank you everybody and bye bye for today.